talking about your design and manufacturing technology, this is sort of like LEDs, right? When you get LEDs off, you have to bin them to get the right color for your particular application. Well, it's similar with quartz, and you guys have to do things to make sure that, you know, lot X is within certain specifications. Talk about that a little bit.
Right. So the crystal manufacturing process, as I mentioned, is a little bit of an art. And to get this rock to be suitable to be put into an oscillator requires a lot of processing. And through that processing, if we were to tighten the specifications very, very closely, the yield would be extremely low. So generally speaking, what we do is we operate within a range, similar to what Brian was speaking of. And then within that range, we know that there are certain bins within that range that we need to tailor our oscillator around. So often what we'll do is we'll get a spec that's perhaps this wide and use a band that's this wide for a specific oscillator and specific components. So we'll bin those and essentially customize each and every oscillator around the very specific crystal that's included in it.
Yeah, it's a very cool process. Now, let's talk a little bit, because I asked you on that tour, how do you take advantage of electronics and Moore's Law, because this kind of stays the same, right? Presumably, maybe you can get pure crystals over time, but you're doing a lot with this particular device on GPS, and you're doing a lot to optimize the crystal in the system.
Right, absolutely. So over time, just to give you an idea, this would be a circa 2003 type of design as a timing solution for one of our customers. And today, the same kind of technology can be represented in this smaller board that's up here with actual enhancements over it. So what happens is the crystal technology does continue to get better in terms of processing. We are able to do things better than we were, 10 years ago, but often it still falls a little bit short of the application needs. So what we'll do is take advantage of circuitry to compensate out some of those things. So crystals can be fairly predictable and linear in nature. So as a very simple example, if we know it's moving in this direction, we can take with a processor or something and compensate that out by offsetting for that slope and bring it back to a nominal setting. So you can achieve very high stability with good precision crystals that are predictable with using processors, microprocessors in there to compensate out.
So this is obviously a huge and crucial market. What keeps you awake at night these days? As you know, you've made this stretch from this to this. You're obviously continuing that sort of innovation. What's just around the bend for you guys?
Well, the phase noise is the key these days, and lowering those phase noise levels. It's inherent from the crystal from the very beginning. So we're working very closely with our crystal manufacturers and ourselves, our own internal capabilities, to lower the phase noise ceilings as much as we possibly can. That's just as the frequencies goes up and the stabilities goes up, those things become much more critical in the system level design. So as frequencies go up, that's the kind of thing that keeps you up at night is really those phase noise levels, and then the stability levels, because everybody wants things to be more precise and more stable for longer. And then of course, we continue to push things into smaller and smaller packages. So the microprocessors and all the technology to continue to shrink those and make them more sophisticated is integral to really getting an oscillator down to perhaps just a crystal and a die or a chip to do everything that this could do at one point in time. So we continue to push for miniaturization as well.